This video is best viewed full screen. Click on the full screen icon at the bottom of your screen to go full screen. In the previous video, we saw how we could display profiles by loading .dat and 1D fits files into rows in this grid. We also saw how we can use the offset and scale tabs to adjust the profile line layout. We needed those adjustments because the curves of the OBAFGKM stars overlapped one another. However, most of the time we're really not interested in the general shape of the curves, which is called the spectral energy distribution, or SED. We're usually more interested in features in our spectra, right? You know, the emission and absorption lines. So to make our presentations more clear, we can remove the SED from our spectra. This procedure is often called normalization or rectification. RSpec has always had the ability to rectify spectra. Here on the RSpec website is a tutorial video that shows how it's done by dividing the spectrum by its continuum. I applied that procedure on the OBAFGKM stars. Let's see what it looks like. I'll select File, Import Zipped Presentation, and then in the same sample spectra folder we saw earlier, open the rectified version of the same files. Those are the same stars we saw in the previous video, but here they don't have those bothersome vertical changes that were due to the temperature and instrument response and other factors like that. That's because I normalized these .dat files before I made this video. Because each star's continuum is horizontal, we don't need to apply as much offset and scaling. So the absorption and emission lines are much more clear. This is a really nice display of the data and is the one that we often see in online and in publications. Okay, so now into our final example. First, to work with a clean slate, I'm going to clear everything in the grid. I'll click on Tools. Now, before I click on Clear All Rows, I want to remind you that if you see a keyboard key here, then that's a keyboard shortcut that you can use rather than the mouse. So F4 on your keyboard, for example, clears the grid. The other shortcut I use a lot is F2 to reload the previous zipped presentation. Okay, so let's clear the grid. And now I'm going to open the appearance screen, and I'll clear the appearances also. Now let's add some spectra from the nova in Perseus in 2020. I'll click on the Add button and select NovaPer 2020 folder. If we look at the file names, we can see that Rayner, who captured these, gave them names that contain the date, so that when we finally load them in one spec into RSpec, the alphabetical sort that RSpec does will put them in date order, which is what we want. There, that's a mesospectra, isn't it? So let's separate them. On the Offset tab, I'll make sure that there's a check mark here. And then I'll use the Offset track bar to separate the spectra out. By displaying spectra like this, you can examine each one and compare it to others that were taken earlier, maybe hours or days earlier or later. As we saw earlier, you can of course give each profile line a different color and add labels if you want, but I won't get into that again. One quick thing here. Notice that the legend contains Rayner's full file names. That's pretty wide and not all that easy to read since there's so much redundant data. Let's make it more readable by shortening the legend lines themselves. First, let's put all the redundant information in the profile title. So, on the appearance screen, I can change the title to include that information. Now we can just type in the legend text that we want in this column in the grid. What I enter here becomes the legend over there. This will take a little bit of time as I type them in, but as I change them here, you can see the legend changing too. Now, doesn't that look great? So one final thing before we finish up. I want to show you that there are two ways to save a presentation. The first way is to select File and Save Presentation. This creates a single, simple presentation file that contains all the information in the grid, the legend, the colors, the file names, and even the offset and scaling settings. And if I widen the grid here, you can see that a saved presentation file even contains the path to the folder from which I loaded the file. So when you or anyone else opens a presentation file, RSpec can reread the source.dat and fits files, but it does that from the same folder they were in when you saved the file. So if after saving a presentation, I delete the .dat or fits files from my computer, or I move the files to a different folder, RSpec won't be able to reopen the presentation because it doesn't know where to find the files. The same thing happens if I email this simple presentation manager file to a friend or post it on a forum. These paths are specific to my machine. The recipient of a file that I send by email or forum posting certainly won't be able to open the file I send because they won't have all the source.dat or fits files on the same exact path on their machine. The File Save Presentation menu is still a good way for you to save data on your machine as long as the source data files stay available in the same folder. But if you want to be sure you and anyone else can always open a presentation manager file, you'd use this Export Zip Presentation with all files option. As the name states, this creates a single zip backup file that contains the presentation info and all the source files. You can then email this zip file to anyone or even post it on a forum. Anybody with RSpec can load and view the full presentation because the file contains all of your source data files. So that's an introduction to how the presentation manager works. In the next video, we'll continue with the presentation manager, showing how it can be used to stitch spectra. You can now use the full screen icon to leave full screen mode. You can now use the full screen icon to leave full screen mode.